So I went to the scrapyard Reclamet in Kent recently, and they gave me a load of stuff, and they had a big bin, and the big bin was full of these things. This is the compressor unit from a fridge. They decommissioned the fridges and chopped it out and chucked it in this skip, and they let me have one, because if you're anything like me, you've always wondered what's inside one of these. I mean, you can look it up on YouTube if you like, but nothing like getting your hands on one and taking it to pieces, because you get a feel for it, and I've always wanted to do that. So of course I grabbed a fridge compressor and I'm going to take it to pieces. Now when you look at these things, it's kind of like a bowl, and it's got a weld lip all the way around there, because these are sealed systems, remember. That gas goes nowhere. It gets heated and cooled and compressed, but it goes nowhere, so it's in a sealed system. So once you get the whole thing cut off, then you can cut around that weld line and take off the top. And what you'll find is a really chunky bit of steel. I mean, that's about 3mm thick, and it's been pressed, and it is extraordinarily heavy, and that's because it's got to cope with the pressures. And when we have a look inside there, we see a motor and a piston, and for what it is, that's actually a beautiful bit of engineering. It's been really nicely made. Let's get the motor out. So here is its connection to the outside world, actually to the rest of the fridge. And we just snip through that, and then the whole motor will lift out. There we go, get it lifted out. We've got a wiring connection there we've got to remove without spilling all the oil, because this is like a sump, and it chucks the oil over everything to keep the motor cool and to lubricate all the parts. So we have to disconnect that wire there. Got a little sump and a whole bunch of springs to take the motor vibration, so there's quite a few springs in there, and as you can see, it's still a fairly chunky piece of steel. Right, that is the motor armature right there, and it's an induction motor, so you've got the armature right there. It doesn't have a bearing on this side, and if I swap it over to that side, there we go, that is our piston pump, and it's, look at the engineering on that, that's just beautiful, isn't it? And you can hear the compressor going as I do that. So we've got the pump here, we've got the motor here, and then we have a valve arrangement on the top here, and the chances are, looking at this, they're just flap valves. And then we've got an intake section here, which is where the gas from here gets pulled in. It actually looks in really nice condition. The operation of a basic compressor is pretty straightforward. As the piston moves down, the operation of a spring valve, just because of the way it's positioned and marked in green, opens, allowing the outside gas from one port to enter the piston cylinder. The piston moves to bottom dead center, and the cylinder is as full as it can get, and then it continues its rotation because it's driven by a motor. This closes the green valve, opens the red valve, and the gas is forced out in the direction of the red arrow. As I said, this is driven by a motor, so that cycle continues, and as the piston reciprocates up and down, alternately closing and opening the red and green valves, the gas on the red side increases in pressure. Okay, it's held on the top here with 4 7mm bolts. So let's undo them. We'll lift that off, and that whole valve arrangement will come off. So there's the intake here. There's a steel piece there with a couple of valve chambers, and here's a stainless steel cover port covering the actual piston. So there's the piston there, and that is obviously an inlet and an outlet, and that has got a tiny spring over it there on that port. So that is the inlet port, because it can only bend that way, and when the pressure of the piston comes back up, it goes through that port, which is the outlet port. So we have an inlet port there and an outlet port there, and that sits on there like that, covering the piston chamber. The piston itself really is, it's got a Scotch yoke arrangement, as you can see right here. Now Scotch yokes obviously change reciprocating motion into rotary motion, which is what that's doing, and that rotation is this is creating the rotation. Equally, if we move the piston, we'll be able to rotate this. So as a motor, the motor runs on the Scotch yoke arrangement, drives the piston. If we want it to be a generator, obviously we drive the piston, and that will turn the motor, and that will mean turning this motor into a generator. So we have a whole unit there, beautifully engineered, which could either be a motor or a generator, with a beautiful piston that is far better than anything we could possibly make, and a valve arrangement. So let's have a bit of a further look into this valve arrangement here. Okay, so remember this is our inlet port pulled from the main chamber, and that goes through this porthole here, which is lined up with that valve there. So that's the inlet valve, meaning that there is the outlet valve, and that's a piece of spring stainless steel, and it has this shape to it on this bulk piece of stainless steel. So on the outlet it can push to the stop and allow the gas out. We have two 10mm bolts here and here. Let's undo them and remove that piston and piston chamber. Isn't that a thing of beauty? So the motor bolt has heads, these here holding the iron yoke on, are just behind these plastic caps. We take those caps off. Okay, so that was a little tough to get out, but there is the stator. It's really rather a beautiful thing, obviously. And here is the rotor, and you can see it's an induction motor. There's no magnets or coils on it, so that's a squirrel cage rotor. Nice hefty lump of steel. And then we have our crank, and this is the bit that went to the Scotch yoke. If you have a look at it, you can see there's little grooves and holes in it because this is splash oiled. So there aren't actually any bearings in there. There are splash oiled bushings. And that goes back together like that. There we go. We can get that in there. There we go. So that goes back together like that. And what we have, obviously, is a support crank and piston all in one. And then we can cut that to be a flywheel and have the basis of a very nice motor sitting right in those parts. Okay, so what's inside a fridge compressor? Well, a beautiful bit of engineering that can be adapted to many other uses. I have seen these made into 2-strokes and 4-strokes and steam engines, and well, you can do that with them. You can make an air engine out of it. You could probably make a Stirling engine out of it. But it's a lovely bit of engineering that I don't stand a chance of repeating. Now, most of them, they just make a flat plate on here as an adapter plate where they do the inlet. And the valve is often a poppet valve or a solenoid valve. They do the inlet and the outlet on the same valve, just by the way you cut the valve. But it is a lovely thing, and we will do something on it for sure, but that's what's inside it, and probably those are the bits that you really want. These things, these are hand crank generators that have been sold all over the internet. You can buy one for somewhere between £35 and £40 on Amazon. And I've read quite a few people doing little reviews of these and say they're quite good. So I thought what I'd do is we'll take it apart and see what's inside. Okay, 4 screws hold it on, take the top off, that's what's inside. It's stupidly simple. This is a DC motor, there's a gearbox, and there's a little control circuit. Let's take it apart some more. So there's the internals removed. That is the DC motor. That's a gearbox. Now it's probably something like, I don't know, 100, 200 RPM at the input to get sort of a couple of thousand RPM on that, so we get a decent voltage, likely to be around about 5 volts or so. If we have a look at the circuit, the motor connects straight to the circuit board. This diode here prevents any power going back should you turn it the wrong way, or if you're charging a battery, then the battery would then run the motor, which would be a little difficult. So the diode prevents reverse current. And then we have this capacitor here, which is 2200 microfarads at 35 volts. And that's a smoothing capacitor. These two can be connected directly across these 2 wires to prevent that reverse current and to smooth the output of this. The rest of this really is to connect to these output ports. That's just a switch, incidentally. Connect to the output ports and do some voltage regulation. So that outputs directly here. You can do exactly the same thing if you used the electronics out of a power bank, or if you just bought one of those sets of electronics, and they're about £1 for the board. And if we take the gearbox apart, there we go, it's a Sun and Planet gearbox. So this is exactly what you'd find in a drill, as it happens. So there's a Sun and Planet gearbox, and there is our motor with its spline. So a drill motor would be as good as this. So just to demonstrate this, I've got a couple of CR2032s, and if I attach them to the leads of what was the generator, There we go, we're turning it because it's a 12-volt motor. So there you go, that is what's the heart of those £40 hand crank generators that are getting great reviews, and it's actually nothing more than a drill. If you take a drill apart, then you're going to get exactly the same thing. You could, if you have a drill where the batteries are dead, just screw a crank handle into the drill and turn that handle, and you're going to be able to cranking about what that does. And the only other bit you need on that is the control electronics, but like I say, that's nothing more than a diode and a capacitor at this point, and then straight into your power battery bank electronics, and you'll have yourself a hand crank generator for next to nothing. Even if you have to buy those electronics, you're talking about £2 or so, which is a hell of a lot better than 40 quid. Now, of course, the same principles apply to any hand crank generator, in fact any generator actually, but any hand crank generator. It's going to have a motor that you're going to be using as a generator, a gearbox because you're cranking it by hand and you want to get it up to some speed to get some volts out, a capacitor to smooth it, a diode to prevent it going back on you when you stop turning, and then a bit of control electronics to even out that voltage so you can charge a battery or charge your phone. But it really is that simple. Anyway, I thought I'd take apart a generator just so you could see what was in it and then hopefully build your own. Look what I came across. It is a portable air conditioning unit. These things are a curse actually, but it should have some interesting bits in it, so let's take it apart and see what we get. You take these apart in the same way that you take everything else apart. Look for a screw and undo it. Okay. Here it is with the case off. Now it is basically a fridge actually, and it runs on the same principle, vapor compression. And let's have a quick look at how a fridge works. At the fridge you've got a whole load of coils called the evaporator, and a cold liquid comes in, turns into a gas, and that energy required to make it a gas pulls the heat out of the refrigerator inside, making the inside of the refrigerator cold. Now it does this because there's a capillary tube called the throttling tube. The throttling tube has a really tiny diameter, about 0.6 of a centimetre, and it means that the high pressure liquid from one side to the low pressure from the other side don't change. They stay as a liquid because the pressure is the same, but the temperature drops from about 55 to -20. It's that change from liquid to vapour that happens inside the evaporator as the liquid evaporates that pulls in that heat. Now, the vapour goes back out to the compressor where it is compressed, but it's compressed into a superheated vapour. It's still a vapour at this stage, and that vapour goes into the condenser coils because the condensation of the vapour gives out the heat, which is where we get the heat in a fridge from, back to the capillary tube as a liquid, a high pressure liquid, and that's it. So there's the evaporator, there's the condenser right there. Here, if I can, there it is, there's the throttling capillary tube going between the two, and this bit is the compressor pump. There's also a fan here to blow the cold air over you, and there's a fan behind this one to blow the hot air off. But that, although used for air conditioning, is just a fridge in a different arrangement. Okay, so I've taken it to pieces. Of course, there were lots of bits. So we've got a couple of ducted fans in there. They're with induction motors, but I've kept them in one piece because I'm pretty sure I'll find a job for those. And of course, a whole load of switches and thermos sensors and bits and pieces. But this is the heart of the system. This is the bit that's just exactly the same as in your fridge, but a bit of rearrangement, it becomes an air conditioner, because what we've got is a couple of really nice radiators here and here, a whole lot of the tubing, there's the capillary tube, and we've got the compressor and motor sitting right inside this welded steel tube here. Now to go any further with this, as I said, I need to have it decommissioned properly. Okay, it's back. It's been decommissioned and separated. Now, if you remember our trip to the junkyard, Reclamet, where they had a bin full of decommissioned compressors out of fridges, you can pick these things up nice and safely just by tripping up to your junkyard and asking for them. But we've got our compressor back, and of course we've got our radiators. Now in here is a compressor piston, which should make a very nice Stirling engine. So we are going to chop this up and have a look at it and see what we can do with that. But of course we do have the radiators, and we can think about heat exchangers and things like that. Hi, So this is another thing I found in the bin. It's a Rexel 250 office shredder, and it's a robust and chunky beast and answers all those needs for destroying your documentation in case somebody's going to steal your identity. But office shredders or shredders, whether they're little ones or big ones, are always the same. And here are the main components in there. We've got a very powerful motor, and here we've got a gear set. So this motor will turn at something like 2,500–3,000 RPM. The gear set will bring it down to roughly 10 to 15 RPM, which is not very fast. But with motors, you always exchange speed for torque. So if you're reducing the speed with a gear set, you get an incredible amount of torque, and that torque goes into these teeth. And when we feed paper through to shred them, we need a lot of torque, and that's what this gearbox does. That's the basic machine. It's obviously covered in paper dust, but let's get it to pieces and have a bit of a better look at it. So now it's out of its cabinet, of course, it's much easier to see the three components that make up the shredder. So here's the motor that I was on about, there's the gearbox, and here's the business end, which is a set of interlocking rotating discs. As they interlock and you feed the paper in, they get pressed between these teeth, and that shreds the paper. Now let's get this to pieces and have a look at the individual components. And once we get the cover plate off the gearbox, here we can see the gears and what was wrong with it. We take out that large gear, you can see it was a nylon gear and it's been shredded there. So unfortunately, that's a bit of a shame, the gearbox isn't any good. But here is the motor, here's one of the drive gears there. So we've got a nice gear ratio going on here. These are the two bits that turn those cutting heads, and there's a ton of torque on them. I can't turn that by hand. Let's take that off. There we go, we've got our motor and the remains of our gearbox, which is a bit knackered because of that one there. Not much when you take it to pieces, is it? So here's our motor. It's an induction motor actually by Brook Compton, which we're an engineer's company in Huddersfield. I used to live near to them. It'll have a thermal sensor in it, so we've got quite a nice motor, because as we saw, it was the gear that went, and these things last forever. Now remember, these can be generators if you spin them above their rated speed. So this rated speed is RPM 1350. So if we spin that at a greater RPM than 1350, that'll actually be a generator. So that's going to be either a useful motor or a useful generator. The gears, I mean, that one's still useful, that one is destroyed, so it's no point keeping it. These are very nice metal gears, you might want to put them to one side. And here's the business end, the cutting head. This section here is just a lot of guide fingers pressed on some steel, so we can remove that and we'll get a couple of bars. And then we have the rotor here, which is a helix. Actually it's kind of really interesting, but it's a helix of cutters on a very hefty steel bar, so we can keep the bar, we can get rid of the cutters. So it doesn't matter what your shredder's for, whether it's a plastic shredder, a tar shredder, a wood chipper, a paper shredder, whatever it is, they all work the same way. They have two rotating blades, a gearbox and a motor. Obviously everything has to be sized to your requirements, so if you're going to be shredding plastic, you want something around about what we looked at in the first shredder. If you want something with wood or tyres, obviously it's a very much chunkier machine, and a metal shredder works in the same way as well. It has those. So this shredder is just a cheaper, more home version, and if we flip it over, it's exactly the same components: motor, gearbox, shredding wheels. Yeah, because this one just lifts straight out. Incidentally, there is an opto sensor right there. LED shines into a sensor. You put a piece of paper or something like that in, it breaks that sensor, and so the opto reader says there's no light and it turns it on. So I like these older shredders actually, because the gearbox is bidirectional. The motor will turn the gears to turn the blades, but if you turn the blades it would also turn the motor. And because we're going from high speed low torque to low speed high torque, if we put a handle on that and turn it, you can see the motor spinning there, and we can relatively easily turn that into quite a powerful hand crank generator. And as my bent is on that sort of thing, then these kind of shredders are great for emergency hand crank generators. Hi, so this is my old Clark 350M mini lathe, and I've had it for years, more years than I care to remember, and recently it blew up. And it blew up in such a way that I don't think I'm going to be able to repair it, so I'm left with a mini lathe. Of course, with something like that, what are you going to do with it? Well, I'm going to pull it to pieces and see what we can do with it. So if I take off this cover, lathe is essentially very simple. I mean, it's a great big lump of steel that's been quite nicely machined, and it keeps everything rigid and safe. But the drive mechanism is this motor here onto that belt that turns the spindle. So let's see if we can get the motor out. So all I've done is remove everything, and there weren't that many screws to remove, and when I say everything, actually not that much. So I've left the heart of the lathe intact, and there it is. Now this is actually the really important bit of the lathe. It's a lump of metal that's been machined, and what's important is things like, it's flat. Is this bit at a right angle to this bit? Does that bit run at a parallel to this bit? So that everything you put in here will be true and square. This bit, does it shatter? Does it move when it's actually working? All of those things, those simple mechanical things, are what are really important about a lathe, because they govern how good the work is that you're going to get out of it. The rest of it is really bells and whistles and a cup holder. So having a button on a lathe that makes you a cup of coffee while you're making whatever it is you make, it doesn't improve what you make. It just means you have something made badly but a hot cup of coffee at the same time. This bit is the bit that's really important. If you get this bit so it's all square and nicely fixed and there's no chatter, then whatever you drive it with is going to come out beautifully. The motor governs how big the work is. If you're going to be turning a great big heavy piece and taking off huge amounts, then you need a pretty powerful motor to do that. If your motor isn't that powerful, well, you're going to be doing small pieces and tiny shavings, which is exactly what this is for, of course, because it's a mini lathe. So the drive motor that came out of this little thing is this. It's a 230 volt, 150 watt, 4000 RPM permanent magnet DC motor, and it's actually in good condition. So I'm not surprised, because although this got a reasonable amount of use, it didn't get enough use to wear that motor out. So that motor is actually in pretty good condition, and you know me, that's going to be destined for some kind of generator at some time or other, because it's a really nice motor for a generator. That's going to work really well. Then of course we got a bunch of switches, nothing wrong with those, and then we got this, which is the controller board. This takes the power in, does the conversion, does the rectification, lights a few lights, and it's got a speed controller on it. That's the bit that blew. So replacing that, you can order a spare part, but to be honest, they're really expensive, hey? So that bit is the bit that's responsible for it going. The rest of it actually is okay. There's nothing wrong with that. It's got plenty of life left in it. So that's not getting thrown away, because that can be used to so many things. I mean, one thing, if I remove the headstock here, of course, what I've got is a cross slide. It's a cross slide set at 90 degrees. It's level. If I bolted that to a drill, I've got myself a milling machine, which is really cool. If you look at lathes, then you'll find that early on, lathes were either treadle-driven, pedal-driven, belt-driven. It was only much later that put motors on them, but the essence of the lathe never really changed. I mean, we've got a few bells and whistles on it, your speed control, reversing, and this one can't thread cut, but there's a few bells and whistles on it later on, but mostly they're just the same thing, and they've been the same thing for about 1,000 years or so. This thing is clearly related to a pole lathe. All you had was a spring pole above, a bit of rope twisted round here, you pressed on a treadle and that spring pole bounced up and down, turning the lathe, and that was the original woodworking lathe that later on became a metalworking lathe. And if you look at a jeweller's lathe, then you've got a handle on here that you turn by hand because your workpiece is so light. So this is still a lathe. All it's actually missing is the drive mechanism. So if we put another drive mechanism on there, sure enough we're going to have a problem with speed control unless we add speed control, but we can put any drive mechanism on there once we've got the heart of the lathe. Just bolt that down, another drive mechanism, bolt the drive input, whatever it's going to be, onto your bench, and you've got yourself a perfectly serviceable lathe. So if you find a lathe and it's on the skip and this bed is actually in reasonable condition, it is worth salvaging, because there's going to be nothing wrong with it. There might be something wrong with the board, there might be something wrong with the motor. This bit is going to take a bit of a clean, and you're going to have yourself the heart of a lathe. Now, I'm not 100% sure what to do with this thing. So I say I could do quite a few things, but I'm going to have to think about it and see what we can actually do with it. But that is the heart of a lathe, in case you've ever wondered. That's what it looks like. Those are the key issues. And when you're looking at lathes, if you're looking at buying one, that is what you should be looking at. The power of the motor to drive it is going to be directly related to the bit of work that you can actually do on it. Whether it thread cuts or reverses is handy, but this is the key to it really. How well made is that? Anyway, I hope you enjoyed the video. Thank you very much for watching. I'll give this some thought. We'll see what we're going to make with it, and of course we'll do a video on it. Anyway, please remember to like and subscribe.